Hello class, today we're going to go over section 4.1, transformations of graphs and symmetry. So our objectives today are to find equations and graphs of functions whose graphs have been vertically shifted, horizontally shifted, stretched, compressed, and reflected. Now, if we look at the shifts of functions, let's look at this example. It says graph the functions the f of x equals the absolute value of x and g of x equals the absolute value of x plus 3 on the same set of axes. What relationship do you notice between the two graphs? Okay, so you can see our graph over here to the right-hand side. We have the f of x equals the absolute value of x function in blue, and the g of x equals the absolute value of x plus 3 in red. And what we can notice is the red function is just the blue function shifted upward 3 units. You can notice there is a plus 3 on the outside. If you look at the table of values here, you can compare the f of x values to the g of x values and just see that there's 3 added to each. So this addition of 3 on the outside just means that we are shifting the graph of f of x up 3 units to get the graph of g of x. So it says the graph of g of x is the graph of f of x shifted 3 units up. Which brings us to the definition for the vertical shifts of graphs. If k is a positive real number, the graph of g of x equals f of x plus k can be obtained by shifting the graph of f of x upward k units. The graph of g of x equals f of x minus k can be obtained by shifting the graph of f of x downwards k units. So a plus on the outside is up, a down on the outside is down, or a minus on the outside is down. Let's look at left and right. So if I graph the functions f of x equals the absolute value of x and g of x equals the absolute value of x minus 5, all on the inside, on the same set of axes, what relationship do you notice between the two graphs? Well, we can see here that the blue graph is the original graph and the red graph is the shifted graph. And we can notice here, if we count it, 1, 2, 3, 4, 5, that the red graph is shifted 5 units to the right. Now, there's a minus 5 in the inside of the g of x here as compared to the f of x. So evidently a minus 5 causes it to shift it to the right. So the graph of g of x is the graph of f of x shifted 5 units to the right. Now, if we're looking at horizontal shifts of graphs, it says if h is a positive real number, the graph of g of x equals f of x minus h can be obtained by shifting the graph of f of x to the right h units. So a minus on the inside is a shift to the right. The graph of g of x equals f of x plus h can be obtained by shifting the graph of f of x to the left h units. So an addition on the inside shifts it to the left. So it says graph the functions f of x equals the square root of x and g of x equals the square root of x plus 3 and then minus 4 on the same set of axes. What relationship do you notice between the two graphs? Well, the blue graph here is your original graph. The red graph is your new graph. Now, the outside should be a shift up and down. The inside should be a shift to the left or right. So if we count it here, we can see that we're shifting down 4 units. 1, 2, 3, 4. And we're shifting to the left 3. 1, 2, 3. And that's how we get from the blue graph to the red graph. So the graph of g of x is the graph of f of x shifted 3 units left and 4 units down. Now let's compare graphs. We want to compare the graphs of y equals k times x squared for k equals 1, 2, and 1/2. Now our original graph is here at A. This is y equals x squared. You can see we have a vertex here at 0, 0. Then our first point is 1, 1. Our second point is 2, 4. For the graph of y equals 2 times x squared, we still have that 0, 0 point at our vertex. But when we get to 1, our output here is doubled. We went from a 1 in the y to a 2 in the y. Okay, still have the 1 in the x, but we went from a 1 in the y to a 2 in the y. Okay, what we've done here is vertically stretched by a factor of 2 because our y value has increased by a factor of 2. If we look at the second point here, 2, 4, it increases to 2, 8 because 4 times 2 is 8. It has been stretched from a 4 to an 8. On the other side of this, if we have k equal a half, and we have y equals 1/2 x squared, that causes a compression. So what happens here is our initial point is still 0, 0 for our vertex. But our next point over here is 1 1/2. So we went from a 1 in our y down to a half in our y. So we have been vertically compressed by a factor of 1/2. If I go to my second point here, we've gone from 2, 4 to 2, 2. 4, half of 4 is 2. We've been compressed by half. Now, the definition of stretching and compressing graphs. The graph of y equals a times f of x is obtained by vertically stretching the graph of f of x using a factor of the absolute value of a if the absolute value of a is greater than 1, and vertically compressing the graph of f of x using a factor of a if 0 is less than the absolute value of a is less than 1. So basically, if I have a number bigger than or equal to, well, there's nothing done if I have it at 1 here, but if it's bigger than 1, whether positive or negative, I'm going to be winding up stretching it. If it's smaller than 1 and a fraction or decimal that's between 0 and 1, I'm going to compress. All right. Now, let's look at reflections of graphs across the coordinate axes. The graph of y equals negative f of x can be obtained by reflecting the graph of y equals f of x across the x-axis. So essentially, if we have a negative added to the outside of the function here, and we're reflecting across the x-axis. But if we have the negative put in the inside of the function, it says the graph of y equals f of x, or f of negative x in this case, can be obtained by reflecting the graph of y equals f of x across the x-axis. Okay, so inside is a reflection across the y-axis, outside is a reflection across the x-axis. Okay, now that pretty much completes this particular section. I recommend going and trying the homework. If you have any issues, please reach out and let me know, and I can help further. I will see y'all next class. All right, I'm going to review the worksheet here just to give you a little extra because that was a quick lecture. So the worksheet for this particular section, I'll read the first question. So to fill in the blank, it says the graph of y equals negative 5 times x minus 2 squared plus 7 can be obtained from the graph of y equals x squared by shifting horizontally. Okay, so it wants to look at the horizontal shift first. Horizontal shifts are on the inside here. So the horizontal shift part will be made up from this minus 2. Now the minus part actually means we shift it to the right. So we are horizontally shifting 2 units to the right, vertically stretching by a factor of, now that's the number multiplied out front. That would be the 5. So vertically stretching by a factor of 5, reflecting across the, now we have this negative out front. The negative out front means we reflect across the x-axis. And shifting vertically, how many units? Vertical shifts are on the outside here. That would be the 7. So 7 units in the, it's a plus here, so we know it's in the up direction. You can say up or upward. I'm just going to write up because that's what I could fit there with my little pen. Now, number 2. Number 2 says the graph of y equals negative 1/5 times x plus 2 all squared minus 7 can be obtained from the graph of y equals x squared by shifting horizontally. So horizontal is the inside. We're shifting 2 units here, but this time we're going to the left. Okay, vertically compressing by a factor of, that'll be the 1/5. Okay, reflecting across the x-axis again because I have the negative out front. And shifting vertically, how many units? 7 units in the down direction, or downward, if you want to try to fit downward in the blank. Okay, let's look at number 3. Number 3 says write the equation of the graph after the indicated transformations. Okay, the graph of y equals x squared is shifted 4 units to the right. I'm going to do it piece by piece. So we started out with a y equals x squared. We're shifting it 4 units to the right. In order for it to be shifted to the right, I had to put that shift on the inside. So it's going to look like y equals parentheses x. Now we're shifting to the right, so I need to subtract here. So x minus 4 all squared All right, that takes care of this piece. Then this graph is vertically stretched by a factor of 6 and reflected across the x-axis. So that means I need to multiply by 6, but it needs to be a -6 because I'm reflecting across the x-axis as well. So it should look like y equals -6 times x minus 4 squared. Okay, that takes care of this piece. Okay, looking at the last piece, finally the graph is shifted 8 units upward. So to shift it 8 units upward, this will be the final answer here. Looking at y equals -6 times x minus 4 squared. Now if it's going up 8, I need to add 8 plus 8. This would be my final answer. All right, and number 4 here, it says write the equation of the function g of x that is transformed from the given function f whose graph is shown. Okay, now the f of x function, the original function, should be x squared. And just keep in mind that x squared is essentially a parabola centered here at 0. Now I did a god-awful job of drawing it there. Let's see if I can do a little bit better. But essentially a parabola centered here at 0, 0, right? Now we want to know how we shift from this parabola to this parabola. What I'm going to do is start at the vertex, which we know the vertex of just an x squared function is 0, 0. I'm going to figure out how to get from that vertex to this vertex. If I start here, I'm going to count down 1, 2, 3, 4. So I'm going down 4 and then to the right 1, 2, 3, 4. Okay, so down 4 to the right 4 is how I'm getting from my initial vertex to my new vertex. Okay, so I'm going down 4, going right 4. Okay, so if I'm starting at f of x equals x squared, then g of x here, if I'm going down 4 and right 4, has to be, okay, right 4 is going to be an x minus 4 on the inside, and then down 4 is going to be a minus 4 on the outside. My function should look like g of x equals x minus 4 squared minus 4. That's how I get from my initial blue function to my new function down here. Hopefully that helps a little bit with some clarification on how to do some of the stuff, and the answers here are attached. You wanted to go back and try it on your own and check yourself. But like I said, if you have any further questions, please don't hesitate to reach out.